Hi and welcome! In this tutorial, we will show how you can create an LLM judge and align it with your human preferences. First, we will explain the process end-to-end, and as a little spoiler, it looks a little bit like a small machine learning project in itself. And second, we will apply this process on real prompts with real data and create an LLM judge that helps us evaluate the quality of code reviews. In the process, we will also compare different models, so stick around if you want to figure out if Anthropic or OpenAI does better. The first step in creating an LLM judge is figuring out what you are judging. Sometimes you already know this. For example, you observed a particular failure mode and now you want to be able to detect it. If you don't know it yet, the best move is to start by labeling your data so that you can figure out some patterns and come up with generalizable criteria. One thing to keep in mind is that you don't need to create an overall judge for your product. You can actually create multiple small judges where each of them evaluates one specific thing. You might want to catch specific failure modes like refusals or repetitions. Or maybe you can flip it around and try to come up with quality metrics which will be proxy for the actual behavior that you want to observe. Of course, there are limits to what you can ask. You cannot say, is this answer medically correct, and expect a reliable answer. But you can ask, is this answer based on the context, or is this answer formulated in a tone that is easy to understand, and so on. You can also come up with more test-specific judges. So if you're working through a particular scenario, you can actually attach a judge to this scenario. Say you're sending prompts that probe your LLM to talk about competitors, and then you have a judge that evaluates if the responses are safe for your brand. You can also have more analytical judges, like for example, classify the responses by intent or topic, just to understand what's going on in your product. I know that some people are skeptical about LLM judges, but this is often because you think that we are creating a judge that blindly sorts all good from all bad. But that's not what we are doing here. We're actually giving them very small, scoped, well-defined tasks. And LLMs are quite good with that. The next step is to create a data set. Before you create a judge, you have to be the judge. There are two ways how you can go about it. First, you can just manually label some responses that you selected, or you can create a simple judge the best you can and then review and correct its responses. Either way, you want to get to a data set where you have ground truth judgments. Once you start labeling the responses, you will very quickly notice that it's much easier to stick to binary or few classes instead of something like a grade of 1 to 10. It may sound appealing at first, but it's actually very hard to be consistent. Your goal is to get to a point where another human can follow your criteria and label responses similarly. If you start labeling and want to adjust the criteria, that's perfect. You want to learn and you want to come up with very good grading. Once you have this labeled data set, you have the ground truth that you can use to evaluate your judge. The next step is to create a judge, which basically means writing a prompt. Effectively, we are prompt engineering a classifier. And yes, you should write these prompts yourself. Even a little bit of domain knowledge can improve the results greatly. And if you're using a tool with built-in prompts, you should always test them against your own labels. Also, do not assume that some more sophisticated method, because it was covered in some research paper, is necessarily better. Always test it against a more simple baseline. Models and prompting techniques are evolving rapidly, and everything will depend on the model you use. For example, simpler models might require more prompt engineering and more examples, and more sophisticated models can do better out of the box. In general, all the usual prompting techniques apply. You should think about writing this judge prompt as if you are given instructions to intern that don't have all your context, so you have to explain it. And all the usual things like chain of thought, more examples, clarity, and so on obviously apply. The next step is to evaluate your prompt. So after you've written your first prompt version, you can run it through your dataset and then compare the responses you get from your judge against the human labels. There are different metrics you can use there. You can use correlation metrics like Cohen's kappa that is usually used to evaluate the agreement between human labelers, or you can use classification metrics like accuracy, precision, recall. Personally, I prefer these metrics because they are intuitive and you can also focus on what matters to you. For example, sometimes precision is more important, sometimes recall is more important because you want to catch more bad examples even if sometimes you are incorrect, and so on. And of course, once you create the judge, you might need to iterate a little bit on this, so that can be like a continuous process where you change the judge and then reevaluate it and then try to make it better. And the last step, of course, is now you can go and apply your judge. For example, let's say that you created a judge that can reliably detect a certain failure mode. Now you can go back to working on your main product, experiment with prompts, with models, and use this judge to evaluate the results and understand if you're getting better or worse. Now, let's try and apply everything that we've just walked through on a real example where we create a judge that helps us evaluate the quality of code reviews. Now, let's start with the code part of our tutorial. What we're going to do now is we're going to look at the data set that I prepared that contains the reviews that are being generated by our imaginary LLM product, and then the reviews that are being given by the human expert as to whether these reviews are good and bad. And then we're going to use it as a base to create an LLM judge to pretty much replicate these labels so that our LLM can also grade our reviews. Now, let's start. The first step is install Evidently, which I already have installed in my environment, and run all the imports that we're going to use throughout the example. Now, we also need to pass some API keys. In this case, I'm going to use two model providers, OpenAI and Anthropic, to use their models as LLM judges, so I need to set them up. Now, I'm also going to connect to Evidently Cloud and create a project. This is optional, but this is useful if we want to track the results of our evaluations and compare them over time. This time I'm doing it through our Python API, and I'm passing the name of the project here. It's LLM Judge Evals. Now let's take a look at the dataset. I actually prepared this dataset for us already, so it's just available on GitHub, and we can download the CSV file and create a pandas data frame in our environment. Let's take a look at what it contains. I'm only previewing the first 10 rows here. Basically what it has is we have a generated review. In this case, the generated review is what we assume our LLM product has given, and this review is related to the code. So we imagine that the use case is that we have some tool that allows to comment on the pull requests that the developers are submitting to some repository. In this case, we're not focusing on the code part itself, but on the tone and quality of the verbal review. And you can see that there are expert labels that pretty much give these labels, right? So they say that the generated review is either bad or good. There is also an expert comment which gives some insight as to why it is good or bad. And this is actually the critical part, because by itself, bad and good says us nothing, but these comments actually contain the criteria that the person was using when giving this review. And if you pay attention, you will notice that the pattern is that most of the comments are related as to whether the review is actionable, like does it give any actual guidance to the user, or what about the tone of the review. So sometimes the tone is slightly condescending or too harsh and so on. So basically you can notice that the comments actually relate to the substance in the review and also to the tone of the review that is given. Now next I'm going to create an Evidently dataset. In this case I'm passing the data definition, which also contains the categorical columns. In this case that's our expert judgment, and I'm creating the dataset object. We can also quickly generate a report that will show us the preview of classes. In this case, I'm using the metric that is called value stats, and I'm passing the name of the column that I want to summarize. You can see that this is the distribution of classes we have. Actually, it's pretty even. So it's 27 are bad examples and 23 are good examples. This is good because this way, when we use this dataset for our LLM judge, we can expect that it's well balanced. So we will cover both the ability to detect good and bad examples. Now, as an optional step, I'm also going to upload this to Evidently Cloud. I'm just doing this because I want to store my dataset to be able to maybe comment on it a bit more or change something if I wish. You can see that I'm using here the add dataset. I'm passing the dataset object that I just created. I give it a name and I also give it a description. Now, if we go to Evidently Cloud, we will be able to see the new project that we created, LLM Judge Evals. And if I go to the datasets, we can see that we just uploaded this dataset. You can see that if we want to change something, like for example, we might want to add something else to the comment or change the label, we can actually do this here. But I'm not going to do it now because we expect that our labeling is already quite good. Now let's review our goals. So we know that we have this task of being able to identify if the review was good or bad. We can try to figure out what our criteria are. If we go through and actually read through all the comments, we can notice some patterns, right? So there was like actionable, not actionable, and so on. We can try to either split it into several different criteria or can try to generalize them into one. I'm going to go with the easy option and try to generalize them as one single criteria. In this case, pretty much the same as the original labeler did, good or bad, but I will try to explain to the LLM judge what we want to achieve. So in this tutorial, I'm going to just repeat myself a few times for us to see how exactly we create this process end-to-end. So let's have the first attempt to create our judge. I'm going to give a name to this experiment because I'm going to use this as a tag for my report. Then I'm going to define the LLM judge prompt. In this case, I'm starting with a very simple prompt. It's basically saying a review is good when it's actionable and constructive, a review is bad when it's non-actionable or overly critical. And I ask the LLM to classify the responses into bad or good. Now, it's not very sophisticated, but it's already giving me some substance, right? So I also have here like a introductory message which explains that we are assessing code reviews. So the next step, I can go and apply this LLM judge. I'm using the descriptor interface, passing our data frame, passing the data definition, and running my LLM judge, in this case using this feedback quality prompt that we have, using OpenAI, GPT-4 Mini, and I'm giving the name to this column as LLM judge quality. Now I'm going to do one more thing here, which is to add an additional descriptor after I run the original LLM judge. In this case, I'm adding a descriptor which says exact match. This will let me understand if there is a match between the LLM judgment and the human judgment by basically adding an additional column true or false, and I'm going to call this column judge alignment. Now let's run and see what we get. So now we are scoring all the responses. In our example, we have 50 responses, so it can take a few minutes. Let's preview the results. In this case, I'm actually opening the whole data frame. And as you can notice, it's actually not very convenient to analyze it this way, right? So we have 50 judgments. Yes, we can look at the judge alignment and we can see that some of them say true or some of them say false, but it's not very convenient to understand, right? So if our judge is doing well or not. So instead, what we're going to do is we can generate a report. Here's what we see, right? So first of all, the distribution of labels that are being given by our judge, it already looks quite different, right? So we can see that we have much fewer bad labels compared to what the human said. We also had a couple of unknowns, so let's see what it is. And here's the judge alignment. So essentially what it says us is that we got a 64% accuracy, which means that 32 of the labels that were given by the LLM judge match the label that was given by a human. However, this pretty much tells us only the accuracy. There are some additional metrics that I want to look at. In this case, if we treat it as a classification problem, there are other metrics like precision or recall. So what we can do is we can actually create a classification quality report using this data set that we have. Now I'm going to create a function that pretty much creates this report because I'm going to be reusing it throughout the further examples as well. So what this function does is, first, it takes the data frame that we have with the human labels and the LLM judge labels, and it also filters the unknowns here. In this case, I'm doing it because I have a binary classification problem and these unknown labels actually don't fit. And I'm going to set up a data definition that fits the classification problem. Remember, until now, we only used it for mapping text columns, but actually, if we deal with a problem like a classification problem, we can use a binary classification mapping where we specify the column that contains the target value. In this case, the target is the expert label, so the human label that we have. And then we have prediction labels. In this case, this is our LLM judge quality. So we're going to compare how well our prediction matches our target. We also have here a parameter that's called positive label, and we basically want to specify which of the two classes we consider our target class, and we'll be evaluating the precision and recall for this class specifically. Now, then we create the evidently dataset object and we run the report. In this case, we include not the text evals that we're already familiar with, but we include something that is called classification preset. This is already including a lot of dataset level metrics that help us evaluate the quality of classification. I'm also throwing a few other metrics, in this case, just to summarize the distribution of the LLM judge quality and the expert label, just for the ease of exploration. Now, I'm also adding the tag to this report, which will let me differentiate between different LLM judge versions, and I'm running this report on my data. Now, optionally, if we set up Evidently Cloud, I'm also uploading these reports to Evidently Cloud. Now, let's run it on our dataset. If you want, you can preview the results locally. So what you see here is that we generated a new report, which actually contains the classification quality summary, but you can also go to Evidently Cloud and explore it there. Now let's understand what this is telling us. In this case, we are looking at the classification quality metrics. We dropped the two unknown labels, right? So the accuracy is slightly different. But what's important is that we have 100% precision. Precision in this case tells us that whenever the LLM gave a label bad, it was correct. However, the recall is only 36%, which means that we only found 36% of our bad reviews, right? And F-score is a balanced measure of this. If you're interested, you can go through all the other metrics just to understand how the report looks. Okay, I'm not very happy with these results, right? So we can probably try and do better. So let's go and try to write a better judge. Before we do, there is one more thing I want to add, which is to create a dashboard which will allow us to track the results of different evaluations over time. You already seen that we can do it directly in the Evidently UI, but this time I'm going to create it using the Python API, which lets me pretty much add a panel to the dashboard directly from Python. So now if we go back to our project, we will be able to see that we just added a new panel, and this panel shows us these three metrics that we care about: accuracy, precision, and recall. In this case, again, we only have one single run, but after we try something else, we'll be able to see if we are improving or not. Now let's try another prompt. Maybe we will be able to improve the accuracy and the recall of our LLM judge. I'm going to call this prompt detailed prompt, and indeed I'm adding quite a few more details. So this time I'm specifying a bit more what I mean by good. So I specify that it has to offer clear suggestions, be respectful, be professional, and so on. And I'm also being much more clear on what bad is. I'm saying that if it focuses on praise only, it is bad; if it's dismissive, it is bad, and so on. To be able to formulate a prompt like this, you need to actually go and read through the commentary, or you can actually cheat a bit and send all these comments to the LLM and ask it to come up with a better prompt. In this case, you might still need to review it, but that's a quick way to actually bootstrap the idea. What's important is to not overfit in this prompt. By overfitting, I mean the well-known concept in machine learning, where essentially the model can memorize the training data instead of discerning the patterns. In terms of prompt writing, it means that if we just put the specific examples in our prompt, chances are that LLM will score them correctly, but will not generalize outside these examples. So instead of putting like the exact if this, judge that, we need to try to explain it more generally. And honestly, I believe that if you read through this prompt, you will be able to actually give judgments yourself, so it already looks to me as something good enough. Now, we're going to repeat the exact same things that we did before. We're just passing the new prompt version and giving it a go. And the second step is evaluating the judge quality. Now I'm going to go again to the Evidently Cloud, and here we see the second report that was generated, which contains the detailed prompt. Wow, it already looks much better, right? So basically what we have here is now 95% accuracy and 92% recall. Basically, it hit a lot of things right. Here is the confusion matrix. Pretty much we see that there are only 2 errors altogether. If we want to explore the errors, we can actually go directly to the dataset and use our judge alignment label to find the 2 errors we have. So these are the 2 errors we got, right? So we had one label where the person said it's bad because it's not very concrete. At the same time, LLM judge considered that refactoring is already a suggestion. Well, maybe. And here we had another example related to the tone, where the person said that the tone is too harsh, but the LLM agreed that it's good enough. Now, but just 2 errors, I think it's pretty acceptable. So maybe we can even stop here and just continue with our main products. We can see here on the monitoring panel as well that we actually improved, so all the metrics went up. However, I want to try if we can make it even better. Let's see. There are a few tricks that you can try which do not even change the substance of the prompt. Sometimes they work, sometimes they don't, because that is just the LLM behavior. So what I'm doing here, I'm keeping the exact same prompt, but I'm adding one line which says always explain your reasoning. Actually, we are already asking for reasoning, but it never hurts to ask twice, so let's see where it leads us. Now here we are, and we got the final report as well. Now let me go and see what we got. Actually, we improved even slightly more, right? Not so much, but we got 98% accuracy. If we take a look, it means that we now have only one error, right? So whatever we did made the judge behave a little bit better. So now if we sort by alignment, let's find the false one. So it fixed the one that was non-actionable, but it still agrees that this comment is constructive. Honestly, if I look at it as a person, maybe I would even agree with LLM, right? So this is the reality that often when we talk about subjective qualities, even humans would not exactly agree on the details, right? So we shouldn't expect 100% alignment as long as it's useful for our main goal. Okay, now I think that I have a very good prompt, right? So however, we are using the model, which is GPT-4 Mini, which is not the most expensive, but slightly more expensive than, for example, Turbo. So let's see if the same prompt is going to work with the simpler model just as well as it did before. So this time I'm creating an experiment with the Turbo name, and I'm passing the corresponding model from OpenAI. Let's run it and run the classification report. Now we're going to go back to the Evidently Cloud and see the new report that we just got. Okay, that is much, much worse, right? So we got only 48% recall, 72% accuracy, well, and lots of errors, right? I don't even have to look at them. So it's much closer to the original results that we got with the GPT-4 Mini and the bad prompt. What it tells us is that it's not just the prompt, right? So it's a combination of prompt and model. And whatever you are doing, if you're using, for example, open source model as a judge, if you're using reasoning model as a judge, you would actually end up with slightly different prompts. What does not change is the process, right? So we can always reevaluate whatever we get against our labels and know where we are, right? If it works, it works. Now, just for fun, I also want to try a different provider. I used OpenAI before, right? Now, so I'm going to try and use Anthropic. I'm also going to import here the Anthropic options because I know that I need to specify the rate limit with the key that I'm using. Well, so I'm creating a new experiment that is called Anthropic. I'm using the exact same prompt, right? So the version number 3 that we were happy with. And I'm choosing this model from Anthropic. So it's Claude Sonnet. Now let's run it. So it took some time to actually get all the scores, but here we are. And we can now also create the classification quality report. Let's go to Evidently Cloud and see how we are doing. So this time we have the 5th report, which is Anthropic. And actually it's very close to the one that we got with GPT-4 Mini and the best prompt we have. So if we want, we can actually go and compare the actual data set to understand if they made the same errors or not. So in this case, the Anthropic made 2 errors. And actually one of them was the same, right? So probably this could be a sign that maybe we need to actually reevaluate our label. And another one was considered to be good because it had some substance, whereas for the human judge it was not enough. Once again, when you look at these results, you could probably say that, okay, there is like a very thin line, so in the end these specific examples could be swayed either way. At the same time, the overall results are pretty good, so either of the judges can work, right? So we can also look at the cost or computation speed, and in this case the OpenAI was actually much faster. So here we go. That is the end of the tutorial. Let me know if you can figure out how to write even a better prompt. If I were to go this route, I would actually try to split the criteria, I think, because I think the actionability and tone can be 2 different evaluators, but it's up to you. I hope you enjoyed the tutorial. Let me know how it works in your workflows.